Hi friends, welcome back to our series of sessions on energy conservation management. We are starting a separate series on electrical systems. So we'll be covering all the electrical utilities, energy conservation of electrical utilities in the videos to follow. But this video pertains to fundamentals of electrical system. As we all know, electrical power system is an aggregate of equipment used to transmit and distribute electricity from sources to consumers. General purpose power supply systems transmit and distribute approximately 90% of the total electricity generated. They link electric power plants with consumers of electricity within electric power systems and interconnect individual systems by overhead or cable power transmission lines. Electric power supply systems ensure reliable, centralized power supply with the required quality and excellent economy to widespread, dispersed locations of consumption. Some electric power supply systems are self-contained and are not connected to transmission lines. For example, the systems used in aircraft, ships, and automobiles. Electrical power systems may be classified according to several characteristics. Depending on their purpose, they may be classified as feeder systems used to transmit electric power, used to transmit distribution systems which distribute power from central substations to consumers, urban, industrial, agricultural, and other users. Classification by voltage divides systems into two groups, those carrying voltages up to 1 kilovolt, those carrying voltage of more than 1 kilovolt. Electric power supply systems may also be classified as by type of current, whether direct current or alternating current, by plant location, overhead or cable, by layout, circular or radial, by normal operating mode, open or closed. In addition to transmission lines, electrical power supply systems also have power substations which are used for the conversion and distribution of electric power and for controlling operation of the system. Electric power system in a country comprise of generating units that produce electricity, high voltage transmission lines that transport electricity over long distances, distribution lines that deliver the electricity to consumers, substances that connect the pieces to each other, and then energy control centers to coordinate the operation of the components. Today, electricity is the most widely used form of energy, mainly because it is easy to generate, transmit, and distribute. It is easy to control. It can be easily converted to other forms of energy like mechanical motion, heating, etc., with very accurate controls required for process. It is cleanest form of energy. And here, if you see, we have the electrical generating station. Then it is coming to, from generated, coming to overhead transmission lines up to 230 kilovolts. Then we have the receiving station. From this, we are getting to the distribution station where it is reduced to 12 kilovolts. And from then onwards, it is coming to commercial customer through underground or transmission lines to commercial customers, industrial customers, residential customers. So this is the very broad network of electricity that is coming from sources to consumers. Sources are electric generating stations, and in between we have the transmission and distribution lines. This is how it goes. Then most widely used form we all have seen, why it is most widely used, why electricity is most commonly adopted source of energy compared to other things. Because of these four reasons, we find that electricity is a more preferable form of energy almost everywhere, whether it is household, commercial, shop, hospital, hotel, small or large industry, or railway traction. Now, the simple generation, if you see, we have at the generation station, we have the step-up transformers. When it is generated at 11 kilovolts or so, then it is stepped up to higher voltages, 120 kilovolts, 240 kilovolts. Then it is transmitted at high voltage through pylon towers. It is transmitted. Then at the distribution, there are again step-down transformers, bring it down to 33 kV or less. And from then onwards, it goes to industry and home consumers at a level of 33. And we have the local substations and the colonies where the voltage is further stepped down from 11 kV to 440 volts. 33 kV to 11 kV, 11 kV to 440 volts and 240 volts, which are used at the household purposes. To see the electricity generation, fundamental principle is always, which was discovered during 1820s and early 1830s by the British scientist Michael Faraday. His basic method is still used, that is, electricity is generated by the movement of a loop of wire or disc of copper between the poles of a magnet. For electric utilities, it is the first process in the delivery of electricity to consumers. The other process like electricity transmission, distribution and electrical power storage and recovery using pumped storage methods are normally carried out by electrical power industry. You see, the electricity generation is generated in a number of ways. The most prominent of all thermal power plants, then hydroelectric power plants and nuclear power plants. There are other ways of producing electricity which are called non-conventional energy sources, which include windmill, solar systems and tidal energy sometimes. The electricity thus generated is needed to be sent to a place where it can be utilized. Such a place could be a household consumer using electricity for his micro oven, or it could be an industry manufacturing cement, paper, etc. The process of sending electricity for utilization is called transmission. And this is the thermal power plant where we have the boilers generating steam, and the steam is fed to the steam turbines, and then from steam turbine to steam condenser, and from there it is going to the cooling tower, and when it is connected to steam turbine is synced with the alternator to produce electricity that is sent through the step-up transformers to the power distribution line. So this is the brief outlay of a thermal power plant. Then if you see the hydraulic power plant, we have the dam, which is the reservoir. Then through the intake, it is given to the turbine, a Pelton wheel sort of a turbine. Then through the draft tube, it goes to the outflow for agricultural purposes. Then the turbine here is synced with the generator, and the electricity generator is sent to the step-up transformer to the transmission lines. Then when it comes to the nuclear power plant, we have the nuclear control rods here, and basically here also, like a thermal power plant, steam is generated in the nuclear reactor, heat is generated in the nuclear reactor, and that is given to the heat exchanger where it heats up the steam, and this steam is given to steam turbine. Steam turbine is synced with the electric generator, and then it is connected to the steam lines. And this used steam comes to the condenser and then to the cooling towers. So this is a very brief about the nuclear power station. So we also have, mostly components of solar power plant where we have the solar modules in terms of photovoltaic array, which is connected. Then we have the inverter or charge controller. We also have a monitoring station, and then battery bank for storage. Then from this onwards, it is given to the transformer, again step-up transformer. We are connecting to AC grid system. Then through the transmission lines, it is given go to the distribution network, and from there distribution we have for residential and commercial power utilization. So if you see the wind turbines, you have a windmill, we have a gearbox, blade gives the power, and gearbox gives connected to the generator. Then this is the tower, and the generated electricity is given to the step-up transformer again, and connected to the grid. So that's exactly what is on generation. Then when it comes to the transmission, the term transmission is used for the process of transporting electricity at a very high voltage, and the transmission is in bulk amount. Normally, this is done at different voltages. In addition to transmission lines, electric power supply systems also have power substations, which are used for the conversion and distribution of electric power and for controlling operations of the system, which is raising and lowering voltages, converting three-phase alternating current to direct current and vice versa, and providing a number of outgoing lines that differ from incoming lines. Voltage is usually lowered or raised in several steps. For each step, there is a separate network of transmission lines and substations through which the electricity is fed to the network operated at the next voltage step. The resulting multi-stage system consists of several interconnected networks carrying different voltages. Transmission is a link between generation and distribution. This is the exact network of a transmission line where we have from the power plant, we are at the generated at 12 kilovolts. Then we have the step-up transformer where the voltage is stepped up to 400 kilovolts. And then it is transmitted through a distances of kilometers together. Then at the distribution level, we have the step-down transformer, again through the substation. And then after step-down transformer, it is brought down to 13 kilovolts or 240 volts, which are given to the residential or commercial purposes. This is exactly what is about the transmission. And if you see the lattice towers where the power is transmitted, we have the conductors and then disc insulators to separate them. We have the jumpers. So this is we will have a network of this kind of lattice towers transmitting the electricity throughout the length and breadth of the country. Then when it comes to electricity distribution, distribution of electricity denotes sending electricity from substations where it is transmitted and received, followed by its distribution to various points of utilization. The substation could be a small place in a village receiving electricity and then distributing it to nearby consumers, or a place where bulk power is received by an industry like aluminum or steel processing industry, etc. So that's about the electricity distribution. We see we have the transmission to this, then we have the power transformers, which is again given to the power station. So if you see the network from the power station, it is stepped up in the power transformer, sent along the lines through transmission lines, again transmission substations, then again distribution substation, where it is stepped down and distributed to different consumers, industrial consumers, residential consumers, and agricultural consumers. This is a very long ring main system of electrical power system. Then if you see the transmission lines, we have the generating station in red color. Then we have the transmission lines, which are moving at 765 volts, 500 volts, 345, 230, and 130 kilovolts. All the transmission is done in kilovolts. And then we have a substation for a step-down transformer, transmission consumer to 26 volt to 69 volts, 13 kilovolts to 4 kilovolts for primary customer, and for secondary customer up to 120 volts to 240 volts. That's exactly happens in an electrical power system. And if you see the Indian Electricity Rules of 1956 regulations, which are the guidelines for electrical standards followed in India, they classify various voltages into different grades. Like low voltages, the voltage need not exceed 250 volts, we classify them as low, and the voltage which need not exceed 650 volts, we classify them as medium, and the voltage which need not exceed 33 kilovolts as high, and which doesn't exceed 33 kilovolt, which exceeds 33 kilovolts, we classify them as extra high voltages. It is important to know why there are different voltages for different stages. Generation at power plants is generally at 11 kilovolts. This 11 kilovolts is then converted into 130 kilovolts, 220 kilovolts, or 400 kilovolts using various transformers. Again, when power is to be utilized at the user end, the voltages are reduced to the required voltages first at 33 kilovolts, 22 kilovolts, or 11 kilovolts for distribution, and then finally to 415 or 3 phases or 230 volts single phase. Generation is at 11 kilovolts because that is considered optimum based on its cost. If one tries to go to a higher voltage, the cost of insulation is very high, and if it tries to go below, the current rating increases, thus demanding a higher size of conductor in generator winding, thereby also increasing the cost. Hence, 11 kilovolts is considered to be the most optimum voltage level for generation. On the other hand, transmission is done at voltage levels of 132 kilovolts and above. Here, the obvious advantage is the use of air as an insulator and the negligible cost of insulation of conductor. The conductor size reduces drastically because current value comes down for the same power handled. Again, if one tries to reduce voltage for transmission, the conductor cost will go up. Hence, transmission is always preferred at extra high voltage. Distribution voltages, of course, again have to be brought down because of the voltage has to match the voltage of utilizing equipment like motors and furnaces, etc. Since a majority of the equipment is rated for medium and low voltage, these voltages have to be brought down at the distribution level. So then if we see the different equipment that are used in electrical power system, is generator is the equipment which converts mechanical energy of rotation to electrical energy. Then we have cables, which are insulated conductors used to provide a flow path to electricity. Breaker, it protects electrical circuits under any abnormal conditions like electrical faults or accidents. Transformer converts the voltage of one level to another level, also changing the current level simultaneously. If the voltage is increased, it is called a step-up transformer. And if the voltage is reduced, it is called the step-down transformer. Then CT stands for current transformer and PT stands for potential transformer. This equipment is used for measurement and protection of in the electrical circuits. Motor converts electrical energy into mechanical energy. There are various types of motors depending on the type of application and which is mostly used in electrical circuits. ACSR conductor stands for aluminum conductor with steel reinforcement, which is used as overhead conductor in transmission and distribution. And finally, the transmission tower is used as a mechanical supporting structure for the ACSR conductor used for the transmission of electrical energy. So that's all we have for today. I hope you have enjoyed this session. Thank you very much.